Hi everyone, my name is Ashwan. Now I'm going to discuss about data-driven meteorology, unveiling insights from weather data. This is the agenda for this presentation. Coming to the introduction part, weather plays an important role in our daily life and in different fields like agriculture, transportation, and events, and etc. This study on weather data insight revealed patterns within the weather data using the historical data set from Kaggle. Understanding weather patterns is essential for planning activities, but the climate is very unpredictable. So we need innovative techniques and informed strategies for sustainable living. Coming to the goal of this study, first thing is to identify cities with most snowy weather, and the next goal is to identify frequent associations between cities and different weather types. And final goal is to develop dependable techniques for predicting the clear weather conditions so that we can plan our activities. This information will be beneficial for travelers who want to plan a vacation or want to go to a hike, also for different fields like transportation, farming, and outdoor events. Finally, it will also help the public to plan their activities according to outside weather. Coming to the data set, the historical weather data from 2012 to 2017 used in this study is sourced from Kaggle. It contains multiple CSV files, which I will walk you through in the next slide. These are the snippets of raw data from Kaggle. It contains multiple CSV files like city attributes, humidity, pressure, wind speed, temperature, wind direction, and weather description. This is useful for weather data insights. This is the snippet of unlabeled data which contains frequency of snowy weather in different cities. This is used for unsupervised learning process. This is the snippet of transaction data in basket format which will be used in association rule mining process. And this is the snippet of label data which will be used for supervised learning. Now coming to the clustering part of this study. Clustering is an unsupervised machine learning algorithm. It is used to group unlabeled data points such that similar data points will be in same cluster. K-means and hierarchical clustering in this study with Euclidean distance as its metric gave similar results, and the optimal number of clusters is 5. And in the map we can see that cities with same color are in same cluster. If we hover over the city, we can find details about the city like name, latitude, longitude, weather details, frequency of snowy weather, and cluster to which it belongs. This image displays 5 different clusters and cities name in each cluster. Cities with most snowy weather are in cluster 3, namely Detroit, Minneapolis, and Pittsburgh. Cities with least snowy weather are in cluster 4, namely Houston and San Francisco. Now coming to the conclusion part for the clustering process in this study, Detroit, Minneapolis, and Pittsburgh experienced frequent and significant snowfall events in this data set. Geographic factors contributes to heightened susceptibility to snowfall for these cities. Houston and San Francisco experienced minimal snowfall occurrence. This is due to warmer climates and geographical location of these cities that helps them to mitigate the snowfall impacts. And clustering analysis from this study provides valuable insights for the cities to adapt and respond effectively to varying snow weather patterns. It also helps in optimizing resource allocation and to mitigate risk and to plan activities during the snowfall. Now coming to the association rule mining part of this study. Association rule mining is an unsupervised machine learning technique. It is used to discover interesting relationships, patterns, or associations among the variables in the large data sets. It requires transaction data. The image here displays top 15 rules by support. Las Vegas and clear weather has highest support, which indicates that they occur together most times in the transaction data. The image here displays top 15 rules by confidence. Las Vegas and clear weather again has highest confidence. It indicates that they occur together most times in the transaction data that contains Las Vegas. The image here displays top 5 rules for snowy weather by confidence. Pittsburgh and snowy weather has highest confidence here. It indicates that they occur together most times in the transaction data that contains Pittsburgh. And it is true because Pittsburgh has highest snowy weather as we discovered it in the clustering part. Now coming to the conclusion part for association rule mining process. Las Vegas, known for its desert climate, experiences predominantly clear skies throughout the year. Clear weather in Las Vegas aligns with the city's reputation as a popular tourist destination and outdoor entertainment hub. Understanding this association between Las Vegas and clear weather can inform businesses and event planners in scheduling outdoor activities and help them to optimize the visitor experiences. And also Pittsburgh, located in the northeastern part of United States, experiences cold winters with frequent snowfalls. The city's proximity to Great Lakes and its elevation contributes to the susceptibility to winter weather systems. Snow weather is a common occurrence in Pittsburgh during the winter months. It often impacts the daily activities and transportation, as it is tough to travel during the snow. Businesses, residents, and local authorities can use these insights from this study to implement snow removal and safety measures effectively. Now, coming to the decision tree part of this study, decision trees are a popular supervised learning algorithms which are used for both classification and regression tasks. They recursively partition the data into smaller regions based on the feature values, ultimately resulting in a tree like structure. Decision tree requires labeled data for training. This study uses decision tree by tuning its parameters to predict the clear weather. The confusion matrix here displays how the model performs on the test data. It displays actual label and the label predicted by the model. This helps in calculating the accuracy of the model. The decision tree models achieved varying accuracy scores for different parameters. The best performing model is the one with entropy criterion and best splitter. It achieved an accuracy of 67.79%. Now, coming to the decision tree in R language for predicting the clear weather. This is the confusion matrix for the decision tree, which has best performance using the Gini criterion. It achieved an highest accuracy of 67.98%. The image here displays the tree structure for the best decision tree model with Gini criterion discussed in the previous slide. It displays different splitting criterions based on different features. Now, coming to the naive Bayes part of the study for predicting the clear weather. Naive Bayes is a popular supervised machine learning algorithm based on Bayes' theorem. It calculates the probability of each label given a set of features and selects the label with highest probability as the prediction. The image here displays the confusion matrix for the Gaussian naive Bayes model used in the study. It achieved an accuracy of 66.85%. Now, coming to the naive Bayes model in R language. The image here displays the confusion matrix for the Gaussian naive Bayes model in R. This model achieved an accuracy of 66.95%. It is a slight increase from the Python naive Bayes model. Now, coming to the SVM part of this study for predicting the clear weather. Support vector machines are supervised machine learning algorithms. They try to find the hyperplane that best separates the label in the feature space while maximizing the margin between the labels. The first image displays the accuracies of different SVM models developed by tuning the parameters like kernel and the cost function. Different parameters for kernel are linear, radial basis function, and polynomial kernel. So the cost functions are tuned from 1 to 50 for linear and radial basis function. But for the polynomial kernel, the cost functions were tuned from 0.0001 to 0.01 as it took long time for the polynomial kernel to run. SVM model with polynomial kernel and cost functions of 0.01 achieved the highest accuracy of 70.1%. The confusion matrix here displays the actual and predicted labels for the best SVM model. The best model for predicting clear weather is SVM model with polynomial kernel and cost function of 0.01. It achieved the highest accuracy of 70.1% and outperformed all other models. Now, to wrap the things, let's get into the conclusion part for supervised learning for predicting clear weather. Predicting clear weather holds significant practical implications for various aspects of daily life, such as planning outdoor activities, scheduling travel arrangements, and organizing events, etc. This study uncovered valuable insights into the effectiveness of weather data insights. The ability to anticipate clear weather conditions allows individuals and organizations to make better informed decisions, which leads to safer and more enjoyable experiences. This study helps in enhancing the capability to forecast clear weather accurately. It ultimately results in improving overall community well being and resilience to weather related challenges. Thank you for watching the presentation.